Assalamu alaikum, myself Arsalan Rizwan. Welcome back to my channel. So in this video I'm going to discuss about solar cell. First of all, we come to its definition. It is an electrical device that converts light energy directly into electricity by photoelectric effect. It is also known as photovoltaic cell. Many solar cells, when combined in series or parallel, make up a solar panel. So in simple words, it is a simple device that converts the light energy from the sun directly into electricity. That electricity is first in the form of DC. Whether or not you want to convert it into a AC or keep it as it is, it's up to you. Now we come to photoelectric effect. Its definition is given as when electromagnetic radiations such as light hit materials, electrons are emitted. These electrons are called photoelectrons. This whole process is called photoelectric effect. So whenever those rays from the sun they hit or fall on the glass of the solar panel, electrons are emitted. These electrons are so called photoelectrons because of the photons that are emitted from the sun rays. Now we come to the applications of solar cell. It is first of all used in satellites in space. You might have seen it in a lot of movies that these satellites in the space have solar panels with them. Source of energy for many households. Yes, of course, it is used in many households to prevent expensive bills and used in solar farms to generate electricity. It is also used in solar farms as a source of uh, electricity because, as I told you, the solar cell creates electricity in the form of a DC. In solar farms, there are inverters that are used to convert this DC into AC so that this energy can further be supplied to many utilities like homes and factories, industries, and many more. It is used in different toys because it won't be expensive as we won't have to change batteries again and again, and it is also used in many household devices along with in transportation. When it comes to transportation, you can think of many cars. Cars do run on solar panels as well these days. So up next is construction. It is made of semiconductors, usually silicon, which is doped with other chemicals. The reason for using silicon is because it is 99.99% purified sand, the second most abundant material in Earth. I may simply present it to you as solar cell is made up of semiconductors, which is not in its pure form, but it is doped with some other materials like some pentavalent and trivalent materials. So the basic reason that we use silicon as a semiconductor in this case is that it is made from sand. However, the purification process is a bit different. First of all, it is purified to 98% pure silicon, then to some 99% pure silicon crystals. Uh, this diagram here shows how the process goes. This is for silica to low purity silicon, then high purity silicon, then to a crucible, then ingot block. It's converted into blocks. After slicing it, they are converted into wafer. Then stacking the wafers in one place like this. These lines here show wafers, and this whole block here is a cell. So these small lines presenting a wafer, and these two lines on top of the cell are the metallic plates. Now coming to the diagram, this diagram here shows the construction and components of a solar cell. The first layer here is made of glass and metal strips. Then comes this blue colored layer, that is the n-type silicon layer. Then then comes this dark green colored layer. It is the depletion region or the PN interface. This light green colored region is simply the p-type layer. After that comes this layer. This is the conductive electrode, just like the metal strips on the top of this solar panel. This last uh, layer is also for electrodes. When wires are connected to both of these electrodes, it completes the circuit, and the main purpose of a solar panel, that is to utilize that electricity, is now complete. Now describing what a p-type and a n-type layer is. A p-type layer is formed when silicon is lightly doped with trivalent impurity like boron, which is deficient of electron. It is kept thick and is about 300 micrometers. In this layer, the majority charge carriers are holes. N-type layer is formed when silicon is heavily doped with pentavalent impurity like phosphorus, which has an extra electron. This is kept thin and is about 0.3 micrometers. In this layer, the majority charge carriers are electrons. Their thickness is kept this way to improve the performance of solar cell. Sorry for that stuttering. To improve the performance of solar cell. And I hope I have written it in very simple words that even you can easily understand it. But to simplify it to another extent, I'm gonna say that p-type layer is simply a silicon that is doped with a trivalent impurity, boron. Boron is a chemical that is deficient of electrons. That means it has hole, and it is kept thick, about 300 micrometers. And then comes the n-type layer. N-type layer is also made of silicon, but with an impurity of pentavalent, like a chemical like phosphorus. It has an extra electron, and this is kept very thin and is about 0.3 micrometers. And the reason to keep it thin and to keep the p-type layer thick is because it helps to improve the performance of solar cell. Now comes the depletion region. It is the region created due to diffusion of charges. It is also named as p-n junction. It acts as a barrier. It is not briefly described here, but I'll try my best so that you can keep up with me. So it is a region that is created due to diffusion of charges. What does it mean? It simply means when, as you know that p-type and n-type layers are only separated by a depletion region. The p-type layers contain those holes and the n-type layers contain those electrons. When they are in contact with each other, some of those electrons and those holes combine with each other and diffuse with each other. In simple words, you can say diffuse with each other, and they form this layer. This layer is simply slower when it comes to movement of electrons from one layer to another. It simply stops those electrons from moving from n-type layer to the p-type layer, and stops those holes from moving from the p-type layer to the n-type layer. So it simply acts as a barrier. So now we come to the working. Oh, of course, sorry about that. I forgot that there are two type of solar cells. Yes, I have not included that in my slides here, but there are two types of solar cells. One is a monocrystalline and the other is a polycrystalline. The one you are being shown here is a polycrystalline one, as it is more widely used when compared to the monocrystalline one. The reason why is that the polycrystalline one is a bit cheaper when compared to monocrystalline one. However, the monocrystalline solar cell is more conductive, more efficient, but still the polycrystalline is expensive enough that most of people cannot afford it. So a monocrystalline makes it even more expensive. So the most abundant is polycrystalline. That is why I have included polycrystalline in my slides over here. So the working of solar cell. Here it is described in brief explanation. The structure of solar cell here is described in brief explanation. The upper layer is glass. This is the transparent terminal. This is the positive terminal. Then this is the n-type layer, the junction, the p-type layer, the semiconductors. Yes, and the energy from the sun. So the energy coming from the sun when enters the solar panel, it creates free electrons, photoelectrons you can say. So of course they move to the n-type region, and the previous electrons that fill up those holes and electrons that are created because of the energy. For the photons are generically considered as energy. So you can say that when photons create these free electrons, they move to the negative terminal of the devices that are you're gonna use, either it is a battery or whatever it is. So this diagram here simply shows how a solar panel works. It works on the principle of photoelectric effect. One solar cell individually produces about 0.58 volts its working is dependent on the intensity of light. When light from sun falls on the solar cells, they release energy in the form of free electrons. These electrons then tend to move. Some light also reflects back, as we are still not able to completely utilize it. And when the circuit is complete, the electrons move into the wire out from the panel in the form of DC. It can be stored in batteries or either converted into AC to be used in power stations and supplied to the society. The last 2 points here are what are the advantages and the disadvantages of solar cells or solar panels. So it is a renewable energy source, as you know. The energy comes from sun, and it is free energy and abundant for us to use, and it would be of our best if we utilize it to the greatest extent, the optimal extent that we can. It is pollution free. It does not cause any pollution those of electricity, like those of electrical power plants that we have that are producing air pollution and damaging over ozone layer. This solar panel is quite efficient in that case. No harm to the nature and the animals. So of course, when there is no air pollution, there is no harm to the nature, and any animals can reduce bills once installed. So this is the tricky point. Uh, they do reduce the bills, but first they require a big amount of money that you need to invest. Though it is still beneficial if you think of it, as it can reduce your bills and you won't be like dependent on the government for those bills as they increase or decrease the value or the cost of electricity, and its maintenance is not that expensive either. So the disadvantages are it does not produce electricity at night. Of course, when there is no sun, there is no photons, there is no sun rays coming to earth. At that time, it does not produce any electricity. However, that electricity is already stored in batteries for household use, so it can easily run throughout the night for your use. And installing a system of solar panel in start is expensive, as I told you. The bigger the unit, the more the expensive the installment is. So you better be careful, and by getting guidance with some proper solar companies so that they could guide you with the optimal solar panel system. In that way, it will be the best use to you, dependent on weather. So it is of course dependent on weather. When the weather is cloudy, there's no sun rays, so it is also dependent on weather. So this was all I could tell you about solar cells. I hope you liked my video, and hope so that you could understand what I was trying to deliver to you. And I'll see you in the next video. Okay.